So in this video, I'm gonna show you how to use chain rule or function of a function to differentiate this type of trig identity. As a prerequisite, check our previous video on function of a function or chain rule and first principle. Okay guys, so if we have y equals sine ax, so in this case we have this. Let's put it in bracket, for example, and you are differentiating variable y with respect to this x. So this a is like a coefficient, which is a constant to x. So in applying chain rule, remember we can say let's represent the whole of this, which is ax. So let u, for example, be equals to ax. Then what are we going to have? We have a y equals sine of u. So what we call chain rule, remember, yeah, we're going to have y. It's now y with respect to u and u with respect to x. So we need to differentiate y with respect to u, and we also need u with respect to x. Okay, remember in our previous video, we said when you differentiate sine function, you get the cosine function. So in this case, we are differentiating sine u, so we are going to get cosine of u. And our u is ax. So when you differentiate ax with respect to s, remember the general principle of differentiation, which is also in one of our previous videos. The power here is 1, for example, and the differentiation says the coefficient or the constant remains the same. The power 1, you drop the power, we write the variable x, decreasing 1 from the power, and that's going to leave you with a times 1a x raised to power 0, and that leaves you with a because x raised to power 0 is 1. Anything raised to the power of 0. So that means our du dx of ax is going to give us a. Remember, your chain rule says you multiply the two functions together, du dx, which literally is going to give you dy dx. As you can see, this can turn out to cancel this. So we now give you our dy du is cos u times du dx is a, and this can be written as a cosine of u. Remember, what we have is dy ds. U is a representation, so you have to replace it back, and that's going to give you, remember, u is ax as we agreed, so we have ax. So this is the result. So one of the easiest way of doing this, if you have an objective question, for example, is it shows that when you have y equals to sine ax, as example, what you should do, if you close sine, for example, differentiate the whole of this, it gives you a. And when you close the whole of this, when you differentiate sine, you know you get a cosine function, replace it back with the variable, you have this. Okay, so as an example, look at a quick one. Let's say we have a y equals to sine of 5x, for example. Remember, so 5 is taking the place of a in this case. So your dy dx is going to be equals to, if you differentiate this 5x, you get 5. If you differentiate sine, you get cos. We write this term back, you have 5x, and that is it. Alright guys, thank you for watching and have a nice time.